Hi, everyone. Welcome to lecture number 7. This is part 2 of the scientific method. So yesterday you should have gotten part 1 when we talked about things like observations, questions, conclusions, results. Today we're going to specifically talk about hypotheses and then conducting experiment and what that takes. So things like variables and all the other different things that you need to keep in an experiment. All right. Again, I'm Mr. Geiselman, one of the ninth grade science teachers. You might have Mr. Oleg, you might have Mr. Swenson, you might have Mr. Kuhn. We're all working together to make sure you guys get all these videos out to you. So let's get started today. So just a quick review from yesterday. The scientific method is a basic guideline used by scientists to solve problems. It's a step-by-step way for us to go through any type of problem and then come to a logical answer. So it starts with an observation. So yesterday we looked at observation, quantitative and qualitative, and we went through how all of those work together. So it is definitely something you do all the time. You might not think about it like this, and you might not break it into these steps, but you do it constantly. Maybe you rode the bus here today, or maybe somebody gave you a ride to school. You made an observation that the car ahead of you, their brake lights were on, right? You ask the question, what's going on? Is there a stop sign coming up? Are there lights? Is there an animal in the road? You asked a question, and then you did some research. And what you did for research was you probably looked ahead and you saw, oh, there are stoplights or there is a stop sign, and you were able to see that. You were able to test your hypothesis. Your hypothesis would have been what we're going to talk about today, but it's going to be your answer to that question. Oh, there is definitely I believe they are stopping because there is a stoplight ahead of us. And you were able to, once you got there, confirm that there was a stoplight. That was your experiment. Now, you didn't really like analyze your data or you didn't report your results, but you came to the conclusion that you were correct and there was a stoplight, and that's why they stopped. So that's the scientific method in a nutshell, and that's really kind of what we do all the time. And now we're just going to kind of do it in a more formal way as we go through this in class. So again, there's observations that we start with. You ask a question, you do some research. Now you form a hypothesis, and a hypothesis is something that we're going to be going over today. So this is going to be a big part of today's lesson is the hypothesis, and you probably all remember it from middle school. It's a pretty big part of any science curriculum because a hypothesis is something that we're going to be testing. It's your answer to that question. Then we're going to talk a little bit about some of the things that go into a test or an experiment. And yesterday, remember, we went through results and conclusion. If you have questions on anything like the observation, the question, how to do research, or even the results or the conclusions, that's something that you should talk to your teacher about and ask some questions, whether it's me, Mr. Oleg, Mr. Swenson, or Mr. Kuhn, because that's stuff that we should have covered yesterday and stuff that we should be pretty comfortable with by now. So moving on today, we're going to jump into what is a hypothesis. And you guys probably remember this old definition of an educated guess. And it is and it isn't. An educated guess is just a little too flimsy for what a hypothesis really is. And a hypothesis is a reasonable answer of what you think will happen in an experiment based on what you know and observe. So an educated guess just isn't quite strong enough to describe what a hypothesis is. A hypothesis has got some background knowledge and some research put into it to create an explanation for what's going to happen. So your hypothesis is going to predict the outcome of an experiment, and it's going to be based on some research, right? What you know and observe. So a hypothesis is the predicted answer to a scientific question based on research and observations. Great definition for that, or great way to use it. When we write a hypothesis, we're probably going to follow this format of if this happens, then this will be the result. It's kind of a cause and effect. If you study for your science test, then you will do better. And actually, that's kind of where we're going to go with this. So I've got a couple for you here. I'm going to give you time to do these and just give us your if-then statement. So you want to see, this is you've observed this, You've asked this question. Now you're going to come up with a hypothesis, right? You want to see if playing music will make plants grow taller. You want to see if that actually happens. Okay. What will be your if I do this or if we do this in an experiment, then this will be the result we see. All right, based on what you know. All right. So a hypothesis for that, come up with one. All right. You also want to see if practicing will improve a player's batting average. All right. So think about softball or baseball, right? You want to see if practicing their batting, okay, practicing in the cage or practicing on a tee, whatever it might be, okay, get specific. If the player practices in a batting cage with a pitching machine, okay, tell me what you think will happen, okay? Come up with your hypothesis. So you should have done that, all right? So if you wanted to see if playing music makes plants grow taller, hopefully you came up with an if-then statement uh, like this. If I increase the amount of music played, then the plants will die, right? That's an if-then statement. That is your explanation to based on what you know that gives you an answer to an experiment or to a question. Now, I don't know where the research for that came from, but that's just an example of a hypothesis. You want to see if practicing will improve a player's batting average. So you're talking about practice, right? And this one is kind of tricky because we wrote it as if I decrease the amount of practice, then my batting average will decrease. You're still testing that relationship between practice and improvement or that batting average, right? But now we just kind of put it in the negative light. So what we were really looking at there were something we call variables. So a variable is a factor that changes in an experiment, and there are two types of variables, right? Variable means to change, and we have an independent variable and a dependent variable. Hopefully you remember from 5th, 6th, 7th, 8th grade that independent and dependent are a little bit different, right? Independent means alone, dependent means it counts on something else. So we'll talk a little bit more about that in a sec. So an independent variable, right, is going to be something that whoever's conducting the experiment, in this case the scientists, changes on purpose. They are purposely going to change the amount of music the plants listen to or the amount that the athlete practices. So the independent variable is the one doing the affecting. It is doing something in the experiment. We're not measuring what happens to the independent variable. We're trying to see how the independent variable changes something else later, right? And independent means by itself, right? Nothing. It's all by itself. It's there alone. Now the dependent variable is that response to the change. All right. So the dependent variable depends on the independent variable, and it's going to be the one being affected. And we're also going to measure dependent variables because dependent variables depend on what we changed in the independent variable. You can think about, or I like to think about, the independent variable as being the thing that you're going to change first, right? This is going to be the thing that you notice first. And the dependent variable then is going to be the thing that you noticed second, or you see a change in second, because it is going to be affected by the independent variable. Or it might not be affected by the independent variable, and your data will tell you whether it has been or hasn't been. So an example, the independent variable choosing to study, I'm sorry, that little bar gets in the way. All right, choosing to study for a science test instead of playing video games. So the independent variable is how you spend your time. So studying for the science test is the independent variable. That is the thing we are changing. What do we measure then on a science test? It's probably going to be the score. So the dependent variable, the thing that you're going to measure later on, is that score on the test. The independent variable, whether you studied or not, probably is going to impact that dependent variable over here, right? Because we all know that studying usually leads to better test scores. So the more you study, the better you usually do. So independent versus dependent variable. So let's do a little bit of practice. You want to see if playing music makes plants grow taller. What are the independent and dependent variables in that situation? Next one. You want to see if practicing will improve a player's batting average. What is the independent and what is the dependent variable in that situation? So again, you wanted to see if playing music makes plants grow taller. All right. The independent variable is the playing of the music, right? You could be playing some hip hop, you could be playing some pop music, you could play some rock and roll, right? The independent variable is the music being played, right? And the dependent thing, the thing we're measuring at the end, is how much the plants grew. The second example, you want to see if practicing will improve a player's batting average, right? The independent variable, the thing changing the stuff at the end or doing the thing you're adding is the practice, right? Your independent variable is the practicing, right? And what are we measuring at the end? And I apologize that it kind of cuts it off here. Ooh, we'll go back, maybe. The thing that we get at the end, right? Our dependent variable is the batting average. That is the thing that is being affected. So the last thing we kind of got to talk about, there's two things left. One of them is constants, right? And to be constant means not changing. So a constant in an experiment is something that has to stay the same throughout the whole experiment. In any good experiment, we are only going to have one independent variable and one dependent variable because that ensures we know the relationship of how the independent variable affects the dependent variable. If we change too many things, then we're not going to know, was it the temperature, was it the amount of water, was it the music, okay? What affected those plants and their growth? So when we're making an experiment, when only testing one variable at a time, everything else should remain constant, which means we don't change any of it. And that's really important because we need to know how that independent variable and only that independent variable affects a situation. So what are some examples of things that would need to stay constant in this example, right? This is the plants example. If I increase the amount of music played, then the plants will die. Come up with as many things that would need to stay constant as possible. So hopefully you came up with a bunch of answers, right? Now, just off the top of my head, right, the type of plant needs to stay constant, right? Whatever type of plant that was. How about the soil? Soil needs to stay constant, right? We can't add more, we can't add different soil, right? Along with that, sunlight needs to stay constant. How about water? How about temperature? How about time of the year? Right? All of these things are constants that need to be there, right? All of these things, and these are just a few of the ones that really should be constant in an experiment. They're just some examples of things that need to stay constant in this example to really figure out, is playing music having any effect on plants, right? We want to know how much they're going to grow. And this one, they say they die, which means 0 for growth, right? That's not good. So the last thing we need to talk about then are control groups versus experimental groups. So when we think of an experiment, we want to have that test group, right? Where we're changing the independent variable and seeing how it affects it. But we really need a group that we call a control group to tell us where the baseline is. So an experimental group is the one that's going to be receiving the variable that is being tested in the experiment. An experimental group in the plant example would have music being played, right? The control group is an experiment that does not receive the variable you are testing. So if we were doing the plant example again, the control group would be the group that had no music playing. So that being said, here's a little scenario. All right. I want you to read this and tell me which one is the control group and which one is the experimental group. So hopefully you figured out, all right, they microwaved two bags of popcorn. One had been in the refrigerator and one had been in their cabinet at room temperature, right? Which one is the control? Well, the control is the one that you didn't do anything different to, right? And they said that they usually store their popcorn in the kitchen cabinet. So the control group, and I again apologize for that slide piece there, is the cabinet group. So the microwave that was kept in the cabinet and then put into the microwave is our control. We didn't change anything with that one. And in the experimental group, we didn't change anything, but we put it in the refrigerator. That's the only thing that changed. We only tested one variable. We didn't test the different brands. We didn't microwave them differently. They were microwaved the same. So the experimental group is the refrigerator group. So all of the popcorn bag that was in the refrigerator falls into that experiment. All right, guys, if you have any questions, please reach out to myself, Mr. Swenson, or Mr. Oleg, or Mr. Kuhn. We're looking forward to seeing you here soon in school. Have a great day, everybody, and we'll talk to you later.